Amber sets off on a hike from the lodge at a bearing of south 83 degrees west. Okay, so with bearings, we're going to be measuring off from a north-south line, and we are going to be measuring off south here, and then we are going to swing around to the west by 83 degrees. So she walks along there for 3.2 miles. And then she changes her bearing. So again, we're going to draw a north-south line. She heads south 15 west. So off from south at this point, we need to go 15 degrees to the west. That's a little bit hard to read here. Let's try that again. 15 degrees. All right, so she moves along this one for 6.4 miles. And now let's see what we want to know here. So we want to find her distance from the lodge. So she's right here, and this was the lodge right here. So we're going to draw a line back up to the lodge, and we want to know that distance. Then in a minute we also want to find her bearing to return to the lodge. All right, as I'm looking here, I've made a triangle. And I know two sides, and if I knew that angle between those two sides, I could use the law of cosines, but I only have part of that angle. I've got this 15 degrees. If we wanted to find this angle right here, we could easily do that using a property of parallel lines. When you have two parallel lines and you have a line across those, then this angle right here and this angle right here are complementary. So they add up to 180. And you could kind of see why, because this angle y right here and this angle are the same size, and those would add up to a straight line. So x plus y equals 180. So if I want to know y and I know x, I can take 180 degrees minus x, and I will have y. So that's exactly what I'm going to do here. I know 83 degrees. I want to know that green one that I have there, and so it's going to be 180 minus 83, and that gives me 97. So this green angle right here is 97 degrees. Well then, the angle in the triangle is just going to be the sum. This whole angle is going to be 97 plus 15. I'm going to put it here since I kind of had room. That's going to be 112 when I add those two together. Well, now I'm ready to use the law of cosines. I got side, angle, side. So let's go ahead, and the side we want to know, squared, equals the sum of the squares of the other two sides, 6.4 squared plus 3.2 squared, minus 2 times the product of those two sides, 6.4 times 3.2, times the cosine of the angle between those two sides, which is 112 degrees. So now we're ready to compute and find x. I am going to go ahead and square root both sides so that we will have x. So I'll put a square root over the top of this. Go to the calculator, make sure you're in degrees, and then I'm going to hit square root of 6.4 squared plus 3.2 squared minus 2 times 6.4 times 3.2 times cosine of the angle between them, which was 112. Finish the cosine. And it looks like we get 8.157, and the directions had said to round this to the nearest hundredth of a mile, so this is approximately 8.16. All right, now the other thing we're supposed to find is the bearing to follow to return to the lodge. So we're right here, and if I make a north-south line, I want this green line going back to the lodge, and it's measured then off from north. It would be that angle right there. All right, well, how could we find that angle? I'm going to use another property of parallel lines. When you have two parallel lines and you have a line going across them, and we want to find this angle right here, it's the same size as this one right here. It's called alternate interior angles, and you can see why, because this plus x plus that angle would add up to 180, because x plus this also does straight line, so those angles must be the same size. And so the one that I want to know up here that's the same size as the bearing angle would be this angle right here. Now I have that measuring off from south all the way over to the blue line was 83 degrees, but I want that other piece. Well, I can solve for this angle in the triangle right here, this little skinny one right in here. I'm going to call that alpha, because now I can actually use the law of sines on this triangle, and I could find alpha because I have an angle and a side opposite pair. And once I know that little angle alpha, I could take the 83 degrees and subtract that alpha, and I would have that one I marked in kind of the hot pink, and that will be the same size as the bearing angle. So let's go ahead and set up a law of sines. So we have sine of 112 degrees over the side opposite, that was the 8.16, will equal sine of alpha. That's the one I want to find. If I go opposite alpha, that's going to be 6.4. All right, let's go ahead and multiply both sides by the 6.4 so that we've solved for the sine alpha. And now I'm ready to get the calculator. And in order to find alpha, I'm going to do inverse sine of this stuff right here. So we got inverse sine of 6.4 sine of 112 divided by 8.16. I'll finish the parenthesis there. And it looks like that angle is 46.65. So alpha is about 46.6 degrees. And what did we need? We needed the pink one, so I'm going to do 83, which was the whole angle there, minus that one we just found, answer, and that will tell me the size of the pink one right here, and that's going to be 36 rounded to the nearest degree, because it did tell us in the bearings to just round to the nearest degree. Well, that's the same size as this bearing angle right here. So how do I write the bearing? I measure off from north, I swing around this direction, which is to the east, by 36 degrees. Now in the computer you won't be entering that degree, but you'll put N36E.